Hess's law. Hess's law is a way to use two or more chemical equations to find the enthalpy of a final equation. So we're going to look at two different types of question here, question 1 and question 2, and they'll show you different types of questions that you could be asked. Now for question 1, you've been given two different thermochemical equations, and question A is asking, what is the enthalpy change value, delta H, for the reaction carbon dioxide yields carbon monoxide and half an oxygen? So we've got carbon dioxide in your question. You've also got carbon dioxide in both of the equations given. Then we're having a look at carbon monoxide. You've only got carbon monoxide in question 1. So you're actually only going to use reaction 1 for part A. So you're trying to get reaction 1, which is 2CO gas plus oxygen yields 2 carbon dioxide. You're trying to manipulate this so that it looks like the reaction in your question. So you might be able to see that you've got carbon dioxide in your question, and it's a reactant. But carbon dioxide here is a product. Carbon monoxide in your question is a product, and your oxygen is a product. Whereas in the equation that you've got the enthalpy for, they're both reactants. So what we're going to have to do is flip it. So when you flip your equation, write it backwards, your enthalpy will have to change the sign too. So we're going to write 2CO2, which is a gas, yields 2 carbon monoxide gas plus oxygen gas. And when you've done that, your delta H is now positive 566 kilojoules. Now this is looking a lot closer to your reaction in the question, but it's still not quite right. You've only got 1 carbon dioxide, 1 carbon monoxide, and half an oxygen. Where here you've got 2 carbon dioxides, 2 carbon monoxides, and 1 oxygen. So now what you're going to do is divide by 2. So you're going to have carbon dioxide, carbon monoxide, and 1 oxygen divided by 2 is half an oxygen. So your enthalpy is going to be 566 divided by 2, which is actually, let's work out what that actually is. 283 kilojoules. And because you flipped it already, it's going to be positive. On now to question part B. What's the enthalpy change value for the reaction carbon plus half an oxygen yields carbon monoxide? This time we're going to have to combine the two equations because we've got carbon, which is in reaction 2, oxygen is in both, but now we've got carbon monoxide, which is only in reaction 1. So we're going to have to combine these two equations in order to get the one that we're asked about. Now, we can see that what you're being asked about requires 1 carbon monoxide as a product. And you've just calculated that 1 carbon monoxide as a product. So we can write that equation, or we will be using that equation. We're also looking at 1 carbon solid, which is exactly as it is. This is a reactant, and this is a reactant. So we're going to be combining these two equations. So carbon solid plus oxygen yields carbon dioxide, and this is 393.5 kilojoules. Now, as I said, using now what you've already calculated, because we've got 1 carbon monoxide as a product, and here we've got 1 carbon monoxide as a product, so we can be writing CO2 gas yields carbon monoxide plus half an oxygen. And delta H, we've worked out, is 283 kilojoules. Now let's make sure that this is going to work out correctly. When we add these two equations together, we're going to have carbon solid. Now, we've got a carbon dioxide as a reactant, but we've also got a carbon dioxide as a product, so we can cancel them. Now, oxygen, we've got 1 oxygen as a reactant, and we've got half a oxygen as a product. So we're going to be able to subtract this over here. 1 minus half gives us half. So we're going to be writing half an oxygen as a reactant yields carbon monoxide as a gas, which is exactly what you're being asked for the enthalpy of this reaction. Minus 393.5 plus 283 is going to give us an answer of minus 110.5 kilojoules. Okay, on to question 2. Calculate delta H for the reaction NH3 plus 5O2 yields 4NO plus 6H2O from the following data. Let's work through it, substance at a time. So, for NH3, where do we have NH3? The only place we have NH3 is in equation 2. And in this, instead of being a reactant, we've got it as a product. So we're going to have to flip the equation. So we're going to be writing 2NH3 gas yields N2 gas plus 3H2 gas. So delta H is now positive 91.8 kilojoules. It's still not quite right because we've got 4 of them here and we've only got 2 of them here. So what you're going to have to do is multiply the equation by 2. So when you multiply the equation by 2, you're going to end up with 183.6 kilojoules. And your 2 will become 4, 1 becomes 2, and 3 will become 6. Okay. On to the next substance, oxygen. Because we've got oxygen in 2 different places, we'll leave that till later. Looking at nitrogen monoxide. We've got nitrogen monoxide in this first equation. Now it's a product here, and it's also a product here, which is marvellous. But we've got 4 here, and we've only got 2 here. So we're going to be multiplying the whole equation by 2. 2N2 gas plus 2 oxygen gas yields 4NO gas. And delta H is going to be minus 180.5 kilojoules multiplied by 2, which is going to be minus 361 kilojoules. Finally, we're looking at water. Water is a product, and the only place we've got water is as a product in reaction 3. Again, it's not quite right because we've got 6 in the equation we're being asked about, and we've got 2 in the reaction we're given the enthalpy for. So we're going to have to multiply 2 by 3 in order to get to 6. So 2 times 3 gives us 6 hydrogens plus 3 oxygens yields 6 waters. Delta H is minus 483.6 kilojoules times 3 minus 1,450.8 kilojoules. Now add it up. We can see 4NH3 gas, then N2, 2 of them cancels out. 6 hydrogens cancels out. We've also got these on the same side. So when they're on opposite sides, they cancel, but when they're on the same side, you add them together. So the oxygens, which I mentioned at the beginning I was going to leave till later, you can see without concentrating on them, we've actually got our 5 oxygens yielding 4NO plus 6 H2O gas. You're now going to add up these numbers, 183.6 plus our minus 361.0 plus the minus 1450.8, and delta H is going to be minus 1,628.8 kilojoules. Hope that helps.